Okay, so our goal here is to write equations for each of these relationships described in, let's say, parts A and B here. So let's look at part A. They tell us that a taxi company charges $1.50 for the first 2 miles of any trip, and then what happens? Well, after that, they start to charge $1.20 for each mile after the first 2 miles. How is taxi fare related to the distance of a trip? Well, it's true that the longer you go, right, the more the trip will cost. But there are two parts to this function right here, or equation. So we can say that our function, or equation, f of x, equals what? Well, for the first part of the trip, what's going to happen? Well, it's always going to be $1.50, right, if you drive for 2 miles. So our function just equals $1.50 when x, right, or t, or however you want to say time, is less than or equal to 2 miles. So if you drive less than or equal to 2 miles, f is $1.50. And you can say more precisely that I guess x would have to be greater than 0, right? So greater than 0, so you're actually driving, but less than or equal to 2 miles. So in that interval there, basically the moment the taxi starts to go, just to get in the taxi, you pay $1.50, and that covers you for the first 2 miles. So I guess we could say x could equal 0. In other words, as soon as you get in the taxi, that's the upfront cost. So now, though, what happens after 2 miles? Well, after 2 miles, you can think about just modeling this out. You have $1.50 plus $1.20 for each mile after 2 miles. So if I drove 3 miles, right, or anything above 2, but if I drove, we'll look at whole numbers here. If I drove 3 miles, it would be what? Well, it would be $1.50. That's for the first 2 miles. And then you would just add $1.20 for the 1 mile after 2 miles. So you've driven 3 miles. 1 mile after 2 miles. So it's 1 mile and 2 miles. That's 3 miles. And that would give you $2.70. So your equation should model this, where for 3 miles, I wouldn't add 3 times 120. It would just be the 1 mile after the first 2 miles plus the original cost. So this function is going to be $1.50, right? Plus, if you think about what we did here to find, right, this piece, that's really like taking $1.20 times, we did 3 miles, but it was really 3 minus 2, because it's the 3 miles you're going in total, but you're subtracting the 2 miles at the beginning. This subtraction tells you how many miles past 2 miles you're driving. So if I drove 3 miles, it's only 1 mile more than 2 miles, so that 1 mile is being charged at $1.20 per mile. As another example, if you had driven, let's say, 5 miles, you think about the cost there, that would equal the $5 to begin with, not the $5, the $1.50 to begin with, right? Plus, well, the $1.20, but really 5 minus 2 times 5 minus 2, because that's 3 miles beyond the first 2 miles, right? 5 miles is 3 miles more than 2 miles. So it's $1.50 plus 3 times $1.20, right? That's $3.60. And you can add these two up. That's $4, $5.10. So that's kind of how this equation works. And really what we're doing each time is we're taking $1.20 or 1.2 and multiplying it by x minus 2. And that's when x is greater than 2. So this is the idea of a piecewise function, that you have to know how much time you're looking at, right? If x is less than or equal to 2, or right between 0 and 2, you know that you're going to use this formula up here, where the answer is just $1.50. If you know the miles or distance is greater than 2, then you could use this formula here. You could simplify it as well. We'll do that over here to the side. Right, so it's $1.50 plus, you can use the distributive property, 1.2x minus 2 times 1.2, which is 2.4. So now this becomes 1.2x minus, well, 1.5 minus 2.4 is minus 0.9. And that could be the formula that you use as well. Either one would be correct. But it's probably better to use the simplified version right here. And that's when x is greater than 2. Now, this is something you get more used to as you try more of these problems. So take, for example, this one right here. An airport offers free parking for 30 minutes. That's our first interval. And then charges $2 for each hour after that. How is the price for parking related to the time a car is parked? So the longer you park, the more it will cost. However, the function, right, is not always the same. When you first enter the parking lot, when, right, time or hours will say, so we won't say f of x, we'll say f of h. That means the function based on h, or hours here, is equal to what? Well, for the first 30 minutes, it is 0. It's free, right? And that's when h is, right, greater than or equal to 0, or less than or equal to 0.5, because we're looking at 30 minutes in terms of hours. We could have used m for minutes, but I'll use hours. Now, after that, we charge $2. So if you think on this part of the formula, when h is greater than zero point 0.5, what's going to happen? Well, really, let's try an example. Let's say you were there for 2 hours. Well, you would think, okay, it was free for the first half an hour, right? But after that, it's $2 per hour. So if you're there for 2 hours, that's 1.5 hours beyond the free part, right? You subtract the half an hour, and what remains is what you're being charged on. So in that case, it would be 1.5 times $2. So you'd be charged $3 in total. So here, the second part of the function, any amount of hours you have, just subtract a half an hour from it, and that will give you your cost, right? So like if I was there for, let's say, 4.5 hours, well then I'd be charged for 4 hours, right, times what? $2, which is $8. So I'm going to fix that one part. It's this times 2. It's $2 times the amount of hours past a half an hour. And that's when h is greater than 0.5. All right, hope this helped.